This is the third video from Chapter 23, Systems of Linear Equations. We have example 284. We'll do part A. There are three parts to example 284. So here we have our system of linear equations. Notice that we have three variables and two equations. That means this is an underdetermined system. Now, think of the variables themselves as questions. These are the things you're trying to solve. These are the things you're trying to find. The equations they represent information. So x1 plus 3x2 plus 3x3 equal to 2 tells you something about x1, x2, and x3. The second equation also tells you something about x1, x2, and x3. With an underdetermined system, the way I think of this is you have more questions than you're given information. So your x1, x2, x3 represents questions. Your equations represents statements. And you have more questions than you're given information. So this is an underdetermined system. An underdetermined system never has exactly one solution. It will either have zero solutions or infinitely many. So we start by looking at the coefficient matrix, A. B, this is the vector we make with our constants to the right of the equal sign. And solving this system of equations is a matter of solving the matrix equation AX equal to B. So to do that, we'll look at the augmented matrix. We'll put it in reduced row echelon form, and it represents, and we have this matrix here. We have two pivot columns, so column 1 and column 2 are our pivot columns. That means that x1 and x2 are our pivot variables. The third column is a free column. So the third column is a free column. That means our free variable is x sub 3. Now the free variable being x sub 3 means we can set our x sub 3 to whatever we want. It's free. So now we want to look at the complete solution. So first of all, let's look at the particular solution. How do we get the particular solution? We set our free variable equal to 0. And we see what's represented here. If our third variable is 0, then x sub 1 is negative 17/5. Our x sub 2 is 7/2. So the particular solution to this system is negative 17/5, 7/2, 0. That's a particular solution. Now, because our coefficient matrix, when we put it in reduced row echelon form, has a free column, that means the null space is non-trivial. So the special solution is a vector from the null space. If you have a vector that is a solution to ax plus b, and you have another vector in the null space, and you add these two vectors together, it is still going to be a solution to ax plus b, because matrix multiplication distributes over vector addition, or it distributes over matrix addition. And so your A times this vector is just 0. So how do we find our special solution? Well, it's an element of the null space. So this time we set our free variable, which is x sub 3, equal to 1. And we look up the third column. We have 0. 0 times negative 1 is 0. We have a 3. 3 times negative 1 is negative 3. So this special solution is really just an element of the null space of the matrix. Sometimes it's a solution to the homogeneous system. So if we had taken our matrix here and changed the augmented matrix to just 0, 0, and put this in reduced row echelon form, these would be zeros. This would be a solution to the homogeneous system. Remember, the null space is a space. That means any linear combination of elements from the null space is also in the null space. And so any multiple that we any real number that we multiply by this vector also gives us something in the null space. And so we have our particular solution plus a special solution times any scalar. And we let that scalar range over R. I called this x sub 3 because x sub 3 is our free variable. We could just as easily call it x. We could call it r, st. A lot of textbooks will use an r, s, or a t here. I like to use the x sub 3 because it reminds us of that x sub 3 is the free variable. And so the complete solution is always our particular solution plus scalars of our special solutions. In this case, we have a special solution. Our null space has dimension 1. So sometimes we have more than one vector here that's a special solution.